We define energy flows and energy fuels, and it's important to understand the distinction between them. A fuel seems pretty self explanatory. It's something that you can hold on to and transform into another form of energy at a time of your choosing. So, gasoline is a fuel we're all familiar with. That's fuel we put in the tank of our car. We can go to the gas station. It's just sitting there in a tank in the gas station. We can put it in the tank in our car, and it will remain there until we decide to convert that stored chemical potential energy into the kinetic energy of the gases when we burn it that drives our car and enables it, the engine of our car, and enables it to go. Other examples of fuels are food. That's also stored chemical potential energy, just like gasoline or coal or natural gas. Uranium that goes in nuclear reactors is also a fuel. Uh, Examples of flows are things where energy is being transported and we can put something into that flow of energy to transform that energy into something useful for us. But if we don't, that energy goes on by and goes through whatever natural transformations it would. So if that sounds sort of abstract, let's give a specific example. Let's take wind. I can put a windmill attached to an electric generator into the breeze, and if I do that, the kinetic energy of the wind blowing by will be converted into electricity, and if that electricity is flowing through my air conditioner or my computer, it will operate, and I will have taken that flow of energy and diverted it from the wind into some electricity. Uh, Even if I put that windmill in the wind and convert that flow of kinetic energy of the wind into electrical energy, if I don't actually use that electricity, the generator just spins, it provides some electricity value, but if I don't take advantage of it, if I don't draw any of that electrical power, that's also lost. So that electrical flow is also a flow. It's use it or lose it. I could transform that electrical flow into stored energy by, for example, charging a battery up. But I wouldn't consider a battery a fuel. I can't go out into nature and discover a lot of batteries. Um, I could, with a sufficiently sophisticated equipment, use that electrical energy to manufacture synthetic gasoline from raw ingredients and reconstitute a fuel that way. But the flow is energy that I can tap into and use instantly or not. And if I don't put a windmill in that wind, the wind goes on by, it runs into trees and mountains, it makes waves in the ocean, and it is converted into other forms of energy, such as heat and kinetic energy of the leaves rustling, the trees swaying, or the waves crashing on the beach. So the energy isn't destroyed, but it goes into some other forms that I can't make use of. Another example of a flow would be sunlight. I can put a solar photovoltaic array in the sunlight, and that will produce something like an instant battery for me. It'll produce available electrical energy, which I can again use to power my electrical appliances. But if I don't, that sunlight is absorbed by whatever it hits instead of my photovoltaic panels, and it heats that up, and that energy is converted from something that I can use, like the energy of sunlight, into something that I can't use as easily, like the warmth of whatever it is that sunlight hit. So the energy is never destroyed, but in a flow, I've got to tap into a useful flow in order to instantly take advantage of that energy. Fossil fuels, the ultimate fuel of fuels and flows, were created by tapping into the flow of sunlight using the process of photosynthesis to convert the flow of sunlight into stored chemical potential energy in the form of the stuff of plants and animals, which when they died and buried and were compressed became our fossil fuels. But it took hundreds of millions of years for that flow to fill up the tank of the Earth's current fossil fuel reservoir. We're burning through 100% of the fossil fuels at the current rate in a matter of only a few hundred years since the start of the Industrial Revolution. That's about 1,000,000 times faster than the flow that created it, which is a problem. If we were using or burning the fossil fuels only as fast as new fossil fuels were being made by the process of photosynthesis, converting sunlight into organic matter, then we could consider that as kind of like a flow. And that takes us to biomass. I can go out, chop down a tree, burn it, use that heat of that burning to cook or generate electricity, and another tree will grow in 20 years. So if I only burn one tree every 20 years, I'm kind of using that fuel of the wood in the sense of a flow. So the difference between a fuel and a flow in some sense has to do with whether or not it has piled up into a reservoir to make a fuel, or whether it is a steady progression and you are taking energy out of it only as fast as that flow of energy is going by.